Good day everyone, welcome again in our video lessons involving quadratic equations. This is now the third video lesson involving quadratic equation. But before we proceed with our task for this video, let us move on first with the home task checking. So last week I've given you this home task in solving the following quadratic equation by extracting the square root. So this time let us check your home task work if you got the correct answers. So for number 1 we have positive and negative 11. For number 2 we have positive and negative 4. For number 3 we have positive and negative 5. For number 4, we have positive 6 and positive 2. And for number 5, we have positive 4 and negative 16. And we have our winner for the win load on home task challenge. Okay? And the winner will receive 50 pesos regular load. I'm going to send it later after this video. So our winner for the win load on home task is now other than Maureen Joyce Ramirez. He got 10 over 10. He answered the 5 items correctly. So 2 points for each item. So she got 10 points, and also she got 50 pesos load. Okay, so I think we are now ready to proceed with lesson number 3, but lesson number 3 is divided into 2 parts because lesson number 3 involves solving quadratic equations by factoring. This is now the second method of solving quadratic equation. The first method is the extracting the square root, and now we're going to discuss factoring. But I'm going to divide this lesson into 2 parts. The first part will be the recall of the different factoring techniques, and then part 2 will be the actual solving of quadratic equation using this particular method. So today we're just going to recall the different techniques used in factoring. So that will be our objective for this video lesson. Okay, so there are 4 factoring techniques that we're going to recall today, and of course we're going to use this knowledge on the part 2 of this lesson. So we're going to discuss here or recall or review the common monomial factor, the difference of 2 squares, the perfect square trinomials, and the general or quadratic trinomials. Okay, so let's go over first with the common monomial factor. Let's say, for example, we are given 2x squared plus 10x. The first thing that we need to do is to get the greatest common factor. So in getting the greatest common factor, we will consider the numerical coefficients and the variables. In getting the greatest common factors, we will have first the greatest common factor of the numerical coefficient. So that is 2 and 10. So the greatest common of the factors of 2 and 10 is 2. And then with regards with the variables, we have x squared in and x. So getting that, we have the common monomial factor of x. And then therefore in 2x squared plus 10x, the greatest common factor is 2x. If we already have the greatest common factor, we will divide the 2 terms of this expression by the greatest common factor. So that is 2x squared divided by 2x and 10x divided by 2x. So we will divide both terms by the greatest common factor. So 2 here will now be equal to 1, and x squared divided by x will be now equal to x. So just have to subtract the exponent 2 minus 1, so that will become x. And then here we have 10 divided by 2, so that is 5. And x divided by x here is now 1. So we have here x and 5. And remember, their operation here is positive. So to write the factor completely, we will write the greatest common factor together with the quotient here, x and 5. But this time we're going to put the operation addition here. So that is the greatest common factor, 2x, and then x plus 5. By the way, this is just a recall. I'm helping you to remember those concept of factoring, so that on our part 2 of this lesson, you'll be able to factor the quadratic equations. So the factors of 2x squared plus 10x is equal to 2x quantity x plus 5. So let's have another example for the common monomial factor. So example number 2, we have 5x squared minus 15x. So again, we get the common factor of 5 and 15, or the greatest common factor, and that is here we have 5. And then for x squared and x, the common monomial, the greatest common factor is x. So that is 5x. So the greatest common factor of this expression is 5x. After that, we divide each term of this expression by 5x. So that will become 5x squared divided by 5x and 15x divided by 5x. So the quotient of this now, since 5 over 5 is 1, that will be cancelled. That is only 1. And then we have x squared divided by x. You subtract the exponent, 2 minus 1. So we have x. Then the other one will be a 15x divided by 5x. X will be now cancelled. That is only 1. 15 divided by 5 is now 3. So to factor this expression completely, you just have to copy the greatest common factor, 5x, and then the quotient here, x, and then the operation from the given, minus, and then we have 3. So the complete factor of 5x squared minus 15x is 5x quantity x minus 3. So I hope you remember how to factor this type of expression, which is called the common monomial factor. Some call this as factoring out. Okay, let us now proceed with the second factoring technique, which is the difference of two squares. In difference of two squares, we have a pattern to consider, in which we are given here a squared minus b squared, in which the two terms here are both perfect squares. And since we are talking about difference here, the operation is always subtraction. So we can factor this particular expression into this. We just have to copy a and b in these two binomial. And then the first one will be addition, and then the other one is subtraction, or vice versa. So a squared minus b squared is equivalent to quantity a plus b and quantity a minus b. So let's go over with this with the example. Example number 1, we have x squared minus 25. Please take note that the two terms must be a perfect square. So for us to know if the variable is a perfect square, the exponent must be divisible by 2. And then the other one, we must know what are the perfect square numbers, like 1, 4, 9, 16, 25, 36, and so on. Those are the numbers obtained by multiplying a number by itself. So in example number 1, we are given x squared minus 25. So all we have to do is to get the square root of the first term and the square root of the second term. So the square root of x squared is x. So we put x on the 2 binomial. And then the square root of 25 is 5. And then we put 5 in the 2 binomial. And all you have to do is to put addition for the first one and subtraction for the second one, or vice versa. Pwedeng mauna yung subtraction and then we have addition. So that the factor now of x squared minus 25 is equal to x plus 5 quantity x minus 5. Next, how about if you have x squared minus 100? Again, the square root of x squared is x. So you put x to the 2 binomial. Then we get the square root of 100, which is 10. You put again 10 to both binomial, and then the first one will be addition, and then the second one will be subtraction, or vice versa. And then the factors of x squared minus 100 is equal to x plus 10 and x minus 10. That's it. Next, let's have x squared minus 4. So get the square root of x squared, that is x. Put x here, 2x, and then square root of 4 is 2. So you put 2 in both binomials, and then put addition and subtraction, or vice versa. So the factors of x squared minus 4 is x plus 2 quantity x minus 2. Plus take note of this recall because we're going to use these concepts in solving quadratic equation by factoring, or the method of factoring, on the part 2 of this lesson. And then number 4, we are given 9x squared minus 16. Please take note, the two terms must be a perfect square. So as you can see, we have 9x squared here. 9 is a perfect square together with the variable, and then here we have 16. Please take note, this must be always in difference. Okay, so the square root of 9 is 3, and the square root of x squared is x, so we have 3x. You put 3x in the two binomials, 3x and 3x, the same. And then the square root of 16 is 4. You put 4 here, and then addition and subtraction. So therefore, the factors of 9x squared minus 16 is equivalent to 3x plus 4 multiplied to 3x minus 4. Let us now proceed with the last example. We are given 25x squared minus 1. So we get the square root of 25x squared and the square root of 1. So the square root of 25 is 5. And then the square root of x squared is x. Then you copy in the other binomial, 5x. And then we get the square root of 1, which is 1. And then you copy on the two binomials. And then one is addition, and then the other one is subtraction. So the factors of 25x squared minus 1 is equivalent to quantity 5x plus 1 and quantity 5x minus 1. And that is the difference of two squares. So let us now proceed with the third one for us to recall, the perfect square trinomial. A trinomial is a perfect square trinomial if it can be factored into binomial multiplied to itself. In a perfect square trinomial, two of your terms are perfect squares. If you do not have the two perfect square terms, then this trinomial is not a perfect square trinomial. We are talking about here the first and the third term. So since we are given the trinomial here, a squared plus 2ab plus b squared, if we're going to factor this particular trinomial, that is equivalent to a plus b times a plus b, or simply we write it as quantity a plus b squared. So we can understand this through examples. As you can see here, we base our operation on the factors on the operation of the middle term. So if the middle term is addition or positive, our operation on the factor is positive. If the operation or the sign of the middle term is negative, or subtraction, the operation of our factors must be also negative. So let's have an example. For example, in the trinomial x squared minus 6x plus 9, both x squared and 9 are perfect squares. So x squared here, the first term, and then the last term or the third term is also a perfect square. So all we have to do is to get their square root of x squared, which is the first term, and then the square root of the last term or the third term, which is 9. And then the square root of x squared, we get x, and then the square root of 9, we get 3. After that, we can factor now x squared minus 6x plus 9 by this. So we get x here and 3, and then minus, because the sign of the middle term is negative. And then we will have two same binomials, x minus 3 and x minus 3. Or we can simply express it as quantity x minus 3 quantity squared. So this expression is now called the square of binomial. So therefore, the factors of a perfect square trinomial is a square of binomials. Okay, so let's have another example. We are given x squared plus 10x plus 25. So again, we can only use this factoring technique if the first term and the constant term, or the quadratic term and the constant term, are both perfect squares. So as you can see, x squared here and 25 are both perfect squares. So therefore, we just have to get the square root of x squared, which is equal to x, and then the square root of 25, which is equal to 5. So therefore, we could factor x squared plus 10x plus 25 as you copy x, and then the operation will be based on the operation of the middle term, or the sign of the middle term, which is addition or positive. So you just have to copy x and then plus 5, and then make it double. We have x plus 5 and x plus 5, or we can simply express it as x plus 5 quantity squared. Okay, let's just have some more examples here. Say for example, we are given 4x squared minus 20x plus 25. So as you can see, the quadratic term 4 and x squared are both perfect squares. And then the constant term here is 25, which is also a perfect square. So we can apply the factoring technique called transforming the perfect square trinomial into a square of binomial. So by that, we get the square root of 4x squared. So the square root of 4 is 2, while the square root of x squared is x. And the square root of 25 is 5. And then we write them as two binomials with the same terms. So that is 2x, you copy this, minus, you copy the sign of the middle term, and then 5. Then make it double, 2x minus 5. Or we can simply express it as quantity 2x minus 5 quantity squared. Please remember the process because we're going to use it on the part 2 of this lesson in factoring. Okay, finally we have 9x squared plus 24x plus 16. So if you can observe, 9 is a perfect square. Of course, x squared is a perfect square. 16 is also a perfect square. So we can apply the perfect square trinomial here by getting the square root of 9x squared, the quadratic term, and the square root of 16, the constant term. So the square root of 9 is 3. The square root of x squared is x. And then we have here the square root of 16, which is equal to 4. After that, you just copy 3x, and then the sign of the middle term, positive. So that is addition, plus, and then the square root of 16, which is 4. And then make it double. We have 3x plus 4 and 3x plus 4. Or simply, we can express it as quantity 3x plus 4 quantity squared. Okay, that's it for the first three factoring technique that we're going to use on the part 2 of this lesson. So, uh, keep it up because we are still recalling the factoring techniques. This is now the last of the 4 factoring techniques. If you need to take this down, please take this down. Write this down and for you to remember, or you can always come back with the video to help you on the part 2 of this lesson in solving quadratic equations by factoring method. So we are now going to factor general or quadratic trinomials. So we have two different ways of factoring general or quadratic trinomials because we have two different conditions. The first one is that if a is equal to 1, let's say for example we are given x squared minus 6x plus 8, in which the coefficient of the quadratic term or the value of a here is only 1. So all we have to do is to think of factors of the third term or the constant term that when you combine, you'll get the numerical coefficient of the middle term. So since the third term or the constant term is positive 8, and then the numerical coefficient of the middle term is negative, what are the factors of 8 in which we will get negative if we combine? So we will think of two factors of 8 in which when we combine we get negative 6. So let us have first the listing of factors. That is negative 1, negative 2, negative 4, and negative 8. So we use negative since we need two factors with the same sign. So that if we multiply two negatives, we will get positive. And then if we add the two numbers, we will get negative. Okay? So we need positive 8 as the product and negative 6 as the result when we combine the two factors. So in these factors, negative 1, negative 2, negative 4, and negative 8, which of the two will result if we combine to negative 6? Okay, correct. That is negative 2 and negative 4. So if we use this, if we multiply them, that is negative 2 times negative 4, we get positive 8. Okay? And if we combine them, that is negative 2 and negative 4. If we combine them, we add 2 plus 4 is 6. And we copy their common sign, which is negative. So therefore, we have our factors, which is negative 2 and negative 4. So how are we going to write them as the factors of x squared minus 6x plus 8? Very simple. We will have two binomials containing the two factors together with x. All you have to do is to put x on the first binomial and then you copy this minus 2. And then the other binomial, put x again and then you get minus 4. The two x's here are the factors of x squared, so that is x times x. And then negative 2 and negative 4 here are the factors of positive 8 that when we combine we get negative 6. So negative 2 and negative 4. So the factors of x squared minus 6x plus 8 is now equivalent to x minus 2 quantity x minus 4. Let us have another example. Okay, what if we have x squared plus 5x plus 4? Again, we need to think of the factors of 4 here. So if a is equal to 1, the factors of x squared is just x times x. And then for 4, we need to find the factors of 4 first. which are 1, 2, and 4. And then we choose two of the factors of 4. We use positive now because the sign of the middle term is positive. So from the first example, we use negative since the sign of the middle term is negative. So this time, the sign of the middle term is positive. So we use the factor of positive 4 as all positive. So that when we multiply the two factors, we get 4. And then when we add, we get 5. So what are the two factors here? Okay, so we have positive 1 and positive 4 because when we multiply 1 and 4, we get the constant term, 4. And then if we combine 1 and 4, 1 plus 4, we get the numerical coefficient of the middle term, which is positive 5. Then we write it as a 2 binomial, x times x. So you put x, 2 x's, separate from the two binomials. And then the factors that we got a while ago, which is positive 1 and positive 4. So the factors of x squared plus 5x plus 4 is now quantity x plus 1 and quantity x plus 4. That's it. Okay, let's go over now with another example. So we are given here x squared minus 9x minus 10. This time we have negative 10 here. From the first two example, we have positive, so it is either both negative factors or both positive factors. So this time we have negative. So the two factors can be positive or negative. The one factor is positive and then the other factor is negative. Okay, so the same manner, we get first all the factors of negative 10. So we have now, since this is negative, we only do this if the constant term is negative. So we have negative 10. The factors are 1, 2, 5, and 10. But since this is negative, it can be positive or negative. Okay, so if we multiply two factors to get negative, one must be positive and then the other one must be negative. And then if we combine the two, the result must be negative 9. So from these factors, we will choose two factors of negative 10 in which will result, if we combine, we will have negative 9. Okay, so that, I think that is negative 10 and positive 1. Okay, let's see. If we multiply negative 10 and positive 1, we get negative 10. If we combine them, we have negative 10 plus 1. Since they have unlike signs, we subtract. So 10 minus 1 is 9. And then we copy the sign of the larger number, which is negative. That's why we have negative 9. And then still we have two x's here, x and x. And then we get negative 10 and positive 1. So the factors of x squared minus 9x minus 10 is quantity x minus 10 times x plus 1. Let's go over now with factoring quadratic trinomial when a is not equal to 1. So we're going to use another technique here. which is the unique trinomial factoring where a is not equal to 1. So what is the unique trinomial factoring? We have a step-by-step method here. Let's say we have 3x squared plus 13x minus 10. So this time, as you can see, we have already the numerical coefficient 3, which is greater than 1. So we use this factoring technique, which is the unique trinomial factoring when a is not equal to 1. By this, we have 3x squared plus 13x minus 10. So since this method is referred to as AC, A is the numerical coefficient of the quadratic term, which is 3, and C is the constant term, negative 10. We start with A, the leading coefficient, and C, the constant. Replace the constant with a multiplied to C. Remove the leading coefficient. So what we're going to do is to multiply the numerical coefficient of the quadratic term to the constant negative 10. So that is 3 times negative 10. And then we will remove the coefficient of the quadratic term. That will become x squared. As you can see, we have a remaining x squared because we remove the numerical coefficient here. So that will become x squared. And then you copy plus 13x. And this time, the constant term will be now the product of 3 here and negative 10, which is negative 30. After that, the new trinomial can be factored easily using the factoring when a is not equal to when a is equal to 1. Okay, so get the factors of negative 30. Probably both 1, since this is negative, two factors are, the first is positive and then the other one is negative. So we get x plus 15 and x minus 2. Let us check. When we multiply positive 15 and negative 2, we will get negative 30. And then when we subtract, since they have unlike signs, this is 15 minus 2, 13. And then you copy the sign of the middle of the larger number, which is 15, that is positive. So that is positive 13. So we have x plus 15 and x minus 2. Next, replace x with the original leading coefficient times x. The original leading coefficient was 3. So this will become now 3x plus 15 and 3x minus 2. What we did is to put 3 again on the two binomials. After that, one of the factors can be factored further. What I'm talking about here is 3x plus 15, in which we can use the common monomial factor. But this time, we're just going to factor out the numerical coefficients. Okay, so since 15 does not have a variable. Okay, so 3 and 15, what is the greatest common factor? Okay, 3. So we factor out 3. So that will become 3 quantity x plus 5. That is by dividing 3x by 3 and 15 by 3. So 3x divided by 3, 3 is cancelled, that become x. Then copy, plus, then 15 divided by 3 is 5. After that, you copy the second factor, which is 3x minus 2. Divide by the original leading coefficient, which was 3, and you will have the final factored form. So the 3 here will now be eliminated because we're going to divide it by the leading coefficient 3. So the remaining factors will be now x plus 5 and 3x minus 2. So therefore the factors of 3x squared plus 13x minus 10 is now x plus 5, and 3x minus 2. Okay, let's have another example. Okay, we are given here 2x squared plus 8x minus 10. So the first thing that we need to do is to eliminate 2 here. So that will become x squared only. Then you copy 8x. So that is x squared plus 8x. And then for the third term, you multiply 2 here and negative 10 here. So 2 times negative 10 is negative 20. After getting this, we factor this quadratic expression with a equal to 1. This can be now easily factored. So that is x plus 10 and x minus 2. Let us check. Positive 10 times negative 2 is negative 20. And positive 10 minus 2 is positive 8. After that, we put again 2 in both binomial. That will be 2x here and 2x here. So that will become 2x plus 10, quantity 2x minus 2. So what we did is we just write 2 here. Then after that, the first binomial here, we're going to factor out 2. So 2x divided by 2 is x plus 10 divided by 2 is 5. And then you copy the second factor, 2x minus 2. After that, we're going to eliminate 2 here to get the factors. So by eliminating 2 here, this will become quantity x plus 5 and quantity 2x minus 2. So therefore, the factors of 2x squared plus 8x minus 10 is r, quantity x plus 5 and quantity 2x minus 2. Okay? Next. Okay, let us have now the final example. We are given here 2x squared plus 5x minus 3. So again, the first thing to do is to eliminate 2. That will become x squared, copy, plus 5x. And then you multiply 2 to negative 3. So 2 times negative 3 is negative 6. After that, we factor x squared plus 5x minus 6. And that is x plus 6 and x minus 1. So we have x times x here for x squared. And then let us check. 6 times negative 1 is negative 6. And 6 minus 1 is positive 5. The next thing to do, so we have now the factors x plus 6 and x minus 1. We put again the leading coefficient 2 to both binomials, so that this will become 2x plus 6. We just added 2 here. And then 2x minus 1. And then the binomial here will be now the binomial to be factored out. We're going to factor out 2. So this binomial will become 2 quantity x plus 3. That is by dividing 2x by the common factor 2. So 2x divided by 2 cancel 2. So that will become x. Copy plus. And then 6 divided by 2 is 3. So that will become 2 quantity x plus 3. And then you copy 2x minus 1. Okay, so next is to eliminate 2 here. We're just going to eliminate them. Then the remaining factors are x plus 3 and 2x minus 1. So the factors of 2x squared plus 5x minus 3 is now x plus 3 and quantity 2x minus 1. Okay, so those factoring techniques are the techniques that we're going to use in solving quadratic equation by factoring, which will be discussed on lesson number 3, part 2 next week. Okay, so let us now proceed with our fast hand exercise. So this time all we have to do is to factor the following. So you have to practice the skills because we're going to use it on the next part of this lesson. So factor the following. I give you 6 items here to answer, and I'll give you 5 minutes to answer these expressions. All you have to do is to factor them completely using common monomial factor, difference of two squares, the perfect square trinomial, and the general and quadratic trinomial. So you may use any of the following methods for each particular condition. Okay, so let us now start your 5 minutes to answer this. Get ready for your pen and paper or scratch paper, and your time starts now. Stop 2 minutes. Okay, we are down to our last minute. Okay, so let us now check your work. Okay, for number 1, 6x squared minus 12x, we have factors are 6x, quantity x minus 2. For number 2, we have x squared minus 64. The factors are x plus 8 and x minus 8. For number 3, x squared plus 10x plus 25, we have the factors x plus 5 quantity x plus 5, or we can simply write it as x plus 5 quantity squared. For 9x squared minus 12x plus 4, we have 3x minus 2 quantity 3x minus 2, or we can simply write it as 3x minus 2 quantity squared. For number 5, we have x squared minus 7x plus 12. We have the factors x minus 3 and x minus 4. And finally, we have 3x squared plus 8x plus 5. The factors are x plus 1 and 3x plus 5. Again, the concept that we use in this video are very useful on our second part of lesson number 3, which is solving quadratic equation by the method of factoring. Okay, so that's the end of this video lesson. Again, we will have now our home task exercise. So I'll give you 60 seconds or 1 minute to copy the home task, and we will answer again this home task before the start of the next video, which is lesson number 3 part 2 of solving quadratic equation by factoring. So get your pen and paper and copy your home task.
The game begins in 3, 2, 1.
Okay, again, thank you for watching this lesson number 3 part 1. See you again on the next part of this video, which is solving quadratic equation by the method of factoring. That is lesson 3 part 2. Thank you for watching. This is Sir Phil, and this is Sir Phil's channel.